Hi, in this demo, we will look at one transmitter that has been wired to the control system. This transmitter has yet been commissioned. So this transmitter in question is this transmitter shown on the CCTV here on the left, which is this transmitter. Yep. Okay. So we can check on the HMI on this transmitter, which is connected to the Honeywell DCS, and from here you can see that the DCS tag name is tank 1 pressure PT, like so. If we double click on the transmitter detail display, now we can see that as soon as the transmitter is connected, there are few fault conditions that is shown here. Number one is device type mismatch fault condition, and number two is device PV range mismatch. From the HUD data, which is seen from the Honeywell HMI, you can see that this transmitter connected is Honeywell ST800, and is connected to a control loop called tank 1 pressure. If we click on the fault and resolution based on the fault condition, you can see that for the first one, device type mismatch, it says the type configured for HUD in the I/O module is different from the actual type of the device, and the solution is to check the HUD device configuration and correct the type mismatch. The second condition is type PV range mismatch. It means that the PV range configured for the HUD device in the I/O module in the DCS is different from the actual PV range of the device. The resolution is to check the HUD device configuration at the device and correct the PV range mismatch. So if we click on the range tab, you can see that what is read from the HUD transmitter is the lower range value is 0, upper range value is 40. However, on the DCS side, the configuration is for 30 for URV and 0 for LRV. So this is the reason for the device PV range mismatch. If we look at the device detail here, you can see that the device tag is 8CHR CTR for the short tag, and for the long tag there is this description which says get HUD supplier to do this. So from here you can see that the DCS tag definition is tank 1 pressure PT, and the device short tag definition is 8CHR CTR, and the device HUD long tag is get HUD supplier to do this. So it's totally a mismatch between the HUD device connected and the DCS configuration here. Also, the HUD revision is found to be revision 7, software revision 105, hardware revision 1. To fix this problem, first let's look at the fault condition again. So the first one is device type mismatch, which says that the device connected is not the same as defined in the DCS. To solve this issue, we would go to the engineering workstation, and this particular channel 10 is where the device found is connected, and the DCS tag definition is tank 1 pressure PT. So if we go to the project tab and go to the same channel, double click on channel 10, click on configuration, and click on HUD configuration. So we need to fix this and configure the right HUD device DD files to that channel. So if we go back to the operator display and look at the device detail, so the device type is ST800, hardware revision 1, hard version 7. So we need to configure the correct DD files according to what is found at the I/O channel. So ST800, hardware revision 1. So if we go back to the engineering workstation, we select the proper one, which is Honeywell ST800 revision 1, and click OK and download and load. So now we are correcting the device type mismatch error. Okay, load is complete. So if we go back to the diagnostic page of this device and look at the fault and resolution page, now the device type mismatch has been resolved. The other thing is device PV range mismatch. It says here that the device found has a range which is different from what is configured in the DCS. And if we click on the range tab, you can see the difference here. 40 URV for the device, 30 at the DCS. So to fix this, we go back to the engineering workstation, double click on the device by going to the monitoring tab, double click on the channel and look at HUD configuration. And here, if you are confident that the right device is connected to this I/O channel and the device range is correctly calibrated as ordered from factory, simply click accept device ranges so that the DCS will upload the device configuration into DCS. Accept changes, and here now you can see that the DCS device configuration ranges are now matching what the device has been configured. Okay. Click OK, and next we would want to check the operator workstation again and see whether this problem is resolved. So if we click on fault and resolution, it shows that now these two faults has been resolved. So the device is now having a correct match between the device range and the device type. Next, what we want to do is now to do the automatic device commissioning procedures for this device. First, we would open the ADC user interface and from this user interface, we would go to the execute and review loop check test. And what we want to do now is to define a loop check test file for this Tank 1 pressure transmitter that we have just added to the system. In this example, we will do the assisted loop check definition file. So we will go to a template which is called assisted AI 5-point loop check test, like this example. Do a copy and then give it a new test name. For example, here transmitter name is Tank 1 pressure PT, and the target channel is Tank 1 pressure PT, and the target control loop is Tank 1 pressure. And this device is a HAT5 device, so we just key in it's a HAT7 device, so we key in HAT7, and it is in the feed section process unit. Click save and close. So now we are ready to do the automatic device commissioning of this one loop called Tank 1 pressure PT. Okay. So it is the loop check test name is Tank 1 pressure PT manual, and it is targeting this temperature transmitter Tank 1 pressure PT. It's a HAT7 device. It's in the feed section of the process unit, and we're going to do assisted loop check. So once you selected this particular transmitter, click execute. Okay, so once we click execute, it goes to this page for us to do ADC. Step 1 is for ADC to do interrogation of this channel to see if the device HAT long tag name matches the tag name defined in the DCS, which is Tank 1 pressure PT. Select interrogate. ADC now is detecting that device, and then the ADC has found that the device tag name is called get HAT supplier to do this. So it does not match the device name defined in the DCS, which is Tank 1 pressure PT. So from ADC, you click on the spanner symbol, and you can rename the device directly from this user interface. So confirm that this is the name that you want the device to have, Tank 1 pressure PT, and click rename device. The ADC will now rename the transmitter to the correct transmitter name. Rename device is in progress. So rename device is successful, and you can see the information here says device has been renamed to Tank 1 pressure PT. Now you can move to the next step, which is to load the changes to the transmitter. Here it says that the channel has been loaded to the controller, so we can skip this step and move to the next step, which is configure device. In this configure device step, ADC will check if the ranges of the transmitter found matches the ranges defined in the DCS. Prior to this step, we have already resolved the issue of the ranges not equal for this transmitter, so we should have a quick success when we do configure step. Here it says device configuration completed because ADC has found that the ranges matches between the transmitter and the DCS configuration. Here you notice that now he has jumped to the automated loop check, and automated loop check has been grayed out because if you remember early on we have used the assisted loop check templates for this particular transmitter and channel. So you can skip this step because there is no automated loop check defined for tank 1 pressure PT. Now we have come to the assisted loop check phase, and here ADC has found a test file for tank 1 pressure PT, which we earlier defined to be using assisted loop check test files. So we can select that channel and execute assisted loop check. So you can see now assisted loop check is in progress, and ADC will launch the user interface for us to do assisted or manual loop check for this tank 1 pressure. So here the commissioning engineer will click execute, and the commissioning engineer is presented with a page to execute a manual loop check of this transmitter. So in this scenario, the technician will go to that transmitter in the plant, hook up all the pressure simulator kits, and then communicate with the commissioning engineer in the control room to coordinate this loop check test in a manual fashion. So commissioning engineer will click start, and the first phase will check and document the information about this transmitter. Here it can be seen that from the HUD device data, you can see that the manufacturer is Honeywell, the device is ST800, and the temperature short tag name is 8CHCTR. The long tag name is now correctly done to become tank 1 pressure PT. The URV is 30, and the low range value is 0. Okay, so we can now ask the operator to set the device at 0%. Confirm after you have given the instruction to the field technician. After the field technician has confirmed they have injected 0% pressure, we click confirm, and the ADC will document the actual pressure found at the transmitter, which is 0.14%. Next, the technician will need to inject 25% value into the transmitter using the pressure toolkit. So confirm if you have asked the operator to set the device at 25%, and once the field technician has confirmed they have injected 25%, the operator at the control room will confirm for the ADC to read the actual value found at the DCS. Okay, as you can see, immediately you see that for 25% point test, it failed because the value found or read by the DCS is still 0.14% instead of 25%, because in this example there's no one pumping the pressure at the transmitter. And we continue for the rest of the point test, which will fail because nobody is pumping the pressure at the transmitter in this example. So this is an example of a manual loop check which is supported by ADC. If you wish to skip the whole test, because in this example there's nobody putting pressure on the diaphragm, so we can click no, and it will move to the rest of the steps until completion. So now ADC is putting together the report of this test. So from here you can see that the test is okay at 0%. At 25%, the value actual reading is 0.14 at the transmitter. At 50% it's the same, 0.12. 75% 0.12 and 100% 0.2. So 4-point test fails and only 1 point is successful. So if you look at the test summary display, you can see that failure is reported on 4 points and only 1 pass at 0%. So you can key in the Honeywell guy involved in the loop check and the client and the date of the test. Which is 23 of June 2020, same as this one. Okay, so once you have documented this, you can close this file and save, and ADC will update the results of this manual loop check, which says the check completed with some errors. So if you wish to repeat this test after you have fixed the issues, you can run this assisted check test again, or go to the next step and close the ADC sequence. So you can click home, review the test summaries, and here you can see that 2 loops check has reported at least 1 error. Click on the bar and you can now see that tank 1 pressure PT manual loop check has failed, and you can check why it fails by selecting the loop check, open the workbook, and review the test result sheet by selecting this tab, and you can see where it fails. So this completes the demonstration on assisted loop check. Thank you.